I should have something to write with and take notes. So we'll be going over motion, speed and velocity, and acceleration today. So Newton's first law. An object at rest will remain at rest. An object in motion will continue moving at a constant velocity, unless acted upon by net force. An object in motion will continue moving at a constant velocity, unless acted upon by net force. Question: is your desk moving? So while the Earth goes around and orbits the sun, your desk is just staying in put, not moving with the Earth?
Yes, it is.
Is the Earth not rotating?
No, it is rotating.
So isn't the desk also rotating around the center of Earth?
Yes, sir. No.
Isn't the sun also moving around the galaxy?
No.
Isn't
No,
the
the sun stays in place.
No, it doesn't. It orbits around the every 100,000 years. It makes a complete orbit around the galaxy. The galaxy is also moving through the universe. My point.
But it's just the little one. No, but we're not the sun. The sun don't move around the sun. We're not the only
We're
not the only sun.
Yes, we move around the sun, but we and the sun also move around the galaxy.
Really?
My point is we need a reference point. Non-moving point from which we measure motion from. Everyone says the desk wasn't moving because you were measuring it from the surface of the Earth. Motion is a change in position and relative to a reference point. So you can see this image of a person running. He is moving relative to the tree. The tree is our reference point, and we measure motion of him moving left to right based on the relative position of him to the tree. You are a passenger in a car stopped at a stop sign. Out of the corner of your eye, you notice a tree on the side of the road begin to move forward. Do trees normally move forward?
No, yes, they go back.
You have mistakenly set yourself as a reference point. We usually will set the reference point to be the surface of the Earth. But motion is defined as defined relative to something else. So relative to your position, the tree is moving away. If you're on a car, you can say that the trees are moving past you. If you're moving on the highway. But we tend to set our reference point to the surface of Earth. We wouldn't say the trees are moving. We're saying that you are moving in a car. Speed is a rate of motion. Is how we describe motion. How fast are you moving? It is defined as the distance traveled per unit of time. Speed is equal to distance divided by time. We let speed be represented by either the letter S or the letter V for velocity. You will often see speed and velocity are treated very similarly, but there is a huge difference between speed and velocity, or at least a significant difference, such as for most of the time you can treat speed and velocity as the same thing, but there is a significant difference between them. Does anyone know the difference between speed and velocity?
Velocity, the increase over the like up and down as well, not just forward?
No. So here the triangle. Again, here they use D to include velocity and speed. So we have an instantaneous speed at a given instant. This is what your speedometer of your car would say, is the speed that you are currently traveling at. We also have average speed. Average speed is the total distance divided by the total time. So if you were to go right now to Lufkin, you're probably going to stop at a stop sign, slow down to make a turn, stop at a red light, you're going to speed up, should be traveling 55 on 1277, 55 miles an hour, and then you can go 75 miles an hour on 103. You're supposed to be going 55 miles an hour. Even though your instantaneous speed is constantly fluctuating, your average speed will be the total distance from here to Lufkin divided by how much time it took you to get there. So, for example, a storm is 10 kilometers away and is moving at a speed of 60 kilometers per hour. Should you be worried? If a storm is 10 kilometers away and it can move 60 kilometers per hour, should you be worried?
Yeah, it's going to be there in 2 minutes.
Well, it depends. What if it's moving away from you?
Well, you get what I mean, right?
This is the difference between velocity and speed. So, just knowing that its speed is 60 kilometers per hour doesn't tell you all that much. We also need to know what direction the storm is coming in. If it's moving away from you at 60 kilometers per hour, no big deal. It's leaving away from you really, really fast. If it's coming towards you, yes, you need to know. So velocity is speed in a given direction. Note that if you change your direction, you also change your velocity, even if your speed doesn't change. So this is the big difference between speed and velocity. Velocity can have a change even when the speed is constant. So if you're going around a circle going constant 55 miles an hour, your speed is constant, but your velocity is changing. Because if your direction changes, your velocity also changes. So velocity depends on both your speed and direction. Make sense? Acceleration. Acceleration is the rate of change of velocity. It is the change in either the speed or the direction. We use the formula that acceleration is equal to final velocity minus initial velocity divided by time. You can also make a triangle too to help you do some of the math. So acceleration is equal to the change in velocity, Vf minus Vi, divided by time. So positive acceleration would be speeding up, and negative acceleration will usually represent slowing down.
Why would we just use accelerating and decelerating?
Deceleration is just negative acceleration. And there's nothing wrong with doing that, but usually we like one word, because if I ask you to solve for acceleration and you get a negative answer, it just means you were decelerating. So you don't know ahead of time in the math if it's going to be positive or negative. So let's do some examples. Your neighbor skates at a speed of 4 meters per second. You can skate 100 meters in 20 seconds. Who skates faster? So when doing these problems, it's a good to start with what you're given. So how fast are you moving at? You're given, exactly. So you're given distance is 100 meters, your time is 20 seconds, and you're trying to find your speed or velocity. So, if you have y'all all used the triangle to do math? So you circle wherever one you want, and your equation would be what's left, d over t. So velocity is equal to distance divided by time. Your velocity is 100 meters divided by 20 seconds. Velocity is 5 meters per second. So you skate faster. So in physics is written in the language of mathematics. You will be doing a lot of math and you will need to show your work. Also, showing your work kind of helps you prevent making stupid mistakes. Everyone good? So, a roller coaster starts down a hill at 10 meters per second. 3 seconds later, its speed is 32 meters per second. What is the roller coaster's acceleration? So it's best to write down the variables. So our initial velocity is 10 meters per second. Our time is 3 seconds. And our final velocity is 32 meters per second. Our equation, so we're trying to solve for acceleration. So it'll be Vf minus Vi over t. So our equation is a change in velocity divided by time. Now all we have to do is plug in our variables. 32 meters per second minus 10 meters per second. That's 22 meters per second divided by 3 seconds is 7.3 meters per second squared. So if you take a meter per second and divide it by second, it's going to double the seconds. You're going to have 2 second variables, and they'll be squared. So, writing down the units. A distance, we're going to usually do meters. Represented by an M. Velocity, or speed. Examples of this is usually going to be meters per second. Other examples would be feet, miles. Miles, we usually do MI, feet, FT. Acceleration. So the equation for acceleration is change in velocity, so Vf minus Vi over time. So acceleration is going to be a meter per second, or speed. So a speed divided by another time unit. So a meter per second divided by seconds. This is the same thing as meters per second times second, which would be meter divided by second squared. This is what we'll mostly use for acceleration. We could also have miles per hour per second. So we have miles, we have an hour, and we have a second. So we have 1 distance unit and 2 time units for acceleration. Units are going to be very important because that's how you identify what the numbers are. So if I tell you that you are moving at, if I say, for example, 1 meter per second per hour, what unit is this? Is it a distance, a velocity, or acceleration? It has 2 time units. It has a second and an hour, so that would be acceleration. Usually, again, we'll be dealing with meters per second. But if I say, for example, centimeters per year, is that a distance, a velocity, or acceleration? It'd be a speed or velocity. Because we have a distance over a time. Distance over a time. Here we have a velocity over a time. Alright, sound travels at 330 meters per second. If a lightning bolt strikes the ground 1 kilometer away, how long would it take you to hear it? How many meters are in a kilometer? What does the prefix kilo mean? 1,000. So 1 kilometer is the same thing. You replace kilo with 1,000. 1,000 meter. So it says sound travels at 330 meters per second. A lightning bolt strikes the ground 1 kilometer or 1,000 meters away. How long will it take you to hear it? Again, I highly suggest that you go and identify all your variables and write them out. So your velocity or speed is 330 meters per second. Your distance is going to be 1,000 meters. Because your velocity or speed is given in meters, your distance has to be in meters. We have to make sure units are matching. And we're trying to figure out time. So we draw a triangle. We're wanting to figure out time. So time is equal to distance divided by velocity. Time is equal to distance divided by velocity. So time is going to be equal to 1,000 meters divided by 330 meters per second. If you were to plug that in a calculator, it'd be something like 3.03 seconds. Does that make sense? Easy? Everyone good? Time before? Alright, how long will it take a car traveling at 30 meters per second to come to a stop if its acceleration is negative 3 meters per second squared? So again, our equation is dealing with a final velocity, initial velocity, and time and acceleration. So how long is asking for a time? So we're looking for a time. How long refers to a time. Initial velocity would be 30 meters per second. What would be the final velocity? 0. And then our acceleration is negative 3 meters per second. So we're trying to solve for time. So it would be VF minus VI divided by A. Plug in our numbers. 0 minus 30 is negative 30. So it would be negative 30 divided by negative 30. This gives you 10 seconds. Makes sense? So is there any questions over the PowerPoint? Everyone good? Let me see. Alright, I believe that's where I'm going to stop today. I'll go over some more examples tomorrow.